G'day. The other day I was repairing a thread on a piece of equipment, used a helical or wound wire insert, and which got me thinking about all the ways you can repair threads. And so this is probably a good clip to talk about the various ways of repairing threads, or putting threads in thin objects, or even just putting threads in to make sure that things don't wear out when it's inconvenient. I'll show you a few ways of doing that. One of the things about threads is that, as a rule of thumb, we say anything over about 2 diameters of the fastener is wasted effort, and so a lot of these inserts and things will have 1 or 1.5 or 2 diameters of thread, and really that's about all you need. A standard commercial nut is about 0.8 of a diameter. You will get some structural nuts which are about 1 diameter. But you know, they're made by proper fastener people and all that sort of thing. So just bear that in mind, that when you're tapping something, when you're putting a thread on, you don't need an enormous amount of thread. Somewhere between 1 and 2 diameters, the thread is ample for pretty much everything. And anything more than that, you're spending a lot of time for no great return. It's all to do with the way that the fasteners stretch in the hole. The brand name that made it famous is probably Helicoil. That is a brand name. They are also made under other names, and this is one of them, Recoil. What they are is a wire thread, and you drill a hole, tap it with the tap that is supplied, and then using the tool, putting the little wire tang down there in the slot, you wind it into the thread you've just tapped. And this is a world first. Can I do this without, do it sideways without breaking it? Okay. Now, yes, I can. Okay, down to the stop. Now, best practice is to wind the insert in so it's a thread or 2 below the top surface there. On the bottom there you've got the tang. Now these can be used on through holes like this, or they can use blind. So if it's blind, I mean if it's a through hole like this, you can just break that off. If it's a blind hole, they do provide a little tool to help knock that thing off. Or you can reach in there with some pliers, or even a set of forceps like this to just remove that. Tang now removed. This bit of plate is a little bit too thin for the insert, and so it wasn't holding on. But the tang is now removed, which means that I can come in with this is an M8 thread insert, so I can come with an M8 bolt and off I go. Now, I'd use these for aluminium if I had a thread that was going in and out quite a lot. You can also use them to repair. So that's another thing they can do. You can put a little bit of Loctite on this when you put it in, just to lock it in. You don't need to, because the springiness of the thread form is enough. But if you do that, don't bolt the joint up straight away. Let the Loctite cure. Otherwise, you might find you can't get the bolt out. These things can occasionally unravel. Putting another one in is just a matter of doing that process again if you've got enough thread left. This demonstration bar here has got several things on it, so we'll work through those. The first one is I guess you'd call it an anti-crush tube. One of the problems with bolting things up to tube is that if you bolt too firmly, you can crush the tube and then you lose all the compression. So one of the things you can do is just get a bit of bit of pipe or bit of tube, and this is my special bit of wire bending tube, so I'm not going to cut it, but what you do is you drill a hole about the OD of the tube, put everything together, just leave a little bit up like so, as little as you can manage, but weld that up on both sides, once again if you can, and what that'll do is that'll give the bolt something to bite on. A variation on that is if you use a bit of solid rod, put that in there, you can weld up once again both sides, and then drill and tap that. So that's a good one if you're wanting to put some threads, particularly beefy threads, in a bit of steel tube like this. The next one here is one that I've seen used on mining equipment a lot, and when I first saw this I thought, oh, you know, why would you want to do that? But nuts are cheap. If it gets damaged, you can just cut off and weld a new one on. And once again, M8 thread just goes in there like so. And so it doesn't matter how thin the tube is, as long as you can get a decent you know, tack or two on there. You know, you can have a proper thread for something to go into. As I said, easily replaceable. I guess it's one big advantage is it's cheap. This is galv tube and it's a galv nut, and I've had to grind the galv off, but if you can get steel nuts on plain steel tube, you're even better off. But yeah, it looks a little bit crude occasionally. One way of securing that properly is to actually put the bolt through there. If you're going to do a lot of these, I'd recommend making some bolts up out of copper, because the spatter doesn't stick to the copper, and so therefore you know, you'll have a much nicer time trying to get the bolt out and all that sort of thing. This one I'm not going to demonstrate. I don't know whether you can make it out there, but that's saying $47 for a packet of 3 of these things, which is a little bit pricey. So I bought this once to repair a cast iron, I think it was a mill, a cast iron column on a mill, made out of stainless steel. And the idea behind these is the instructions tell you to tap a particular size. You tap that, and then you knock these little keys down, hence the name Nutserts, and that then locks that into that tapped thread. You make up a little, what would you call it, punch like that to knock them in. This one's been battered around, so I'd need to straighten that out. But you knock that in, and that gives you a really strong thread. So once again, if you've got a damaged thread in something that can't readily be fixed, or you've got an aluminium or a zinc or something that you need to have a decent thread that you can thread in and out, things like this or the helicoils are the go. This device here is called a Nutsert. Several people make them. You can get them in various materials, steel or aluminium, whatever. This one's got some serrations around the head. There are others with serrations around the body, and works similar in a way to a blind rivet, pop rivet. You put a mandrel in there, and then that bulges up and clamps the material, and allows you then to use that as a nut. These are great if you're once again using tube and you haven't got access to the other side. You might want to put it for an inspection panel or something like that. You can use these things. You can put them on thin sheet as well. So quite a good way of getting around things. That's a complete fitted Nutsert. This one's an M6, and so you know that's quite a nice tight fit. If you pull these too hard, you can distort them, so you need to be careful of that, but most of the time you're pretty right. The thread is slightly recessed, which can actually be a good thing. The only problem is that there's a raised collar there. Some of them are a little less raised than that, but you know, with all of these things there are drawbacks and things. Things like this, the helicoils, all that sort of thing, they're around about $5 a piece, so it's not the sort of thing that once again you want to do it on a whim, but in terms of something where you need a nut to hold something on, that's not a bad method. The tool I used here is actually a King Chrome tool. Not sponsored, no connection, I just been looking for one of these style tools for a while, and to my surprise they have them. This sort of Nutsert, very similar to others. This is for thin sheet metal, I guess. But once again, threads onto a mandrel, and you can get interchangeable jaws of all sorts for these things. And then that may not want to work for me without a piece of metal in place. See, oh, there we go. And then by turning this, you're pulling this wedge piece into Is it working? Can't tell. You're pulling this wedge piece into here, expanding it out, it'll grab into the metal. Not terribly common in Australia. This one actually came from the US. I got it for a particular job at one stage. It's not a it wouldn't be my choice of things, just because it requires a little bit of technique and fiddliness, and once again the nuts are rather expensive, and they're CAD plated too, which is now a no-no. This last style of nut here is one that you're unlikely to run across in the home workshop. It's actually a press nut, and when making mass production press metal parts, these are a hole is put into the panel, and then these are pushed in, and it clips into those little grooves there and provides you a nut. As I said, not used terribly much. These came from a factory who made refrigerators. These days there are other ways of forming these things. You can have thread forming taps, which use a shaped hole basically, and cuts a thread into it. There are other ways of doing things. I mean, you could just get a piece of flat bar, put some holes in it, and weld that onto something if you wanted a thread. This last one I want to tell you about is called a Pimps, or it goes under the brand of Pimps fastener. What they are is basically a push-in fastener. So if you can imagine, that's the material. This is just a section. There's a mirror image down here. The fastener itself has got a thread in here, and it's plain balsa here. That's got a serration on it, and there's a little undercut there. And so what happens is that you drill a hole the same size as that, and you push them together. Once that's done, you've extruded a little bit of material into that undercut, and the serrations have bitten into the parent material, the sheet material, and so that's a rock solid fastener. So these are certainly a premium sort of fastener. And I don't use them. I just haven't got that sort of money, but they are quite a good fastener, and they're used in quite a number of industrial situations for fasteners, pretty much the same way that the riv nuts and all those sorts of things are. Anyway, I hope this has been of interest to you, and I hope it gives a few people some solutions to some of the problems they may be having with fasteners in sheet material, or even thread repairs.